Hey everyone and welcome back. Now in today's video we'll be discussing at a very high level overview about virtual private cloud, also referred as the VPC. So let's understand this with a simple use case. So let's say that you have a John who works as a finance manager. Now he's migrating to a new city because of his job and plans to live in an apartment. So generally whenever you migrate to a new city, you have to find a new apartment. That is the first thing that you will generally do. So in the diagram as well, you'll see that there are multiple houses which John has to find and select. Now in a similar way, when we talk about the analogy of servers, let's say that you have 5 servers which are planned to be migrated to cloud. So these 5 servers can be within a data center or they can be a different environment altogether. So when you migrate it to cloud, in our case AWS, then also they have to find a place where they can stay. And that place where the servers can stay is called as the VPC. So if you will see, in case of John, since he was migrating to a new city, he had to live in a house or an apartment. Similarly, servers which can typically be in a data center, when you migrate your applications which are present within a server to cloud, then you will have to launch new servers within this VPC. Alright, so this is where you go ahead and launch new servers in AWS. Now let's understand the second part of this analogy, where John has decided to buy a new house, and for an additional income he has decided to rent a part of his house. So in order for John to be able to rent it, what he has done, John has decided to partition his house. So this house he has partitioned into two, so that one part of his house he can go ahead and rent it. Now same goes typically in Bangalore. If you'll see, the landlords, they partition the house 4 or 5 times, and there are 4 or 5 families who are living within the same house. So similarly here, John has decided to do it 2 times, so he'll have a pretty big house, and that is what this specific use case states. Now in a similar way, as far as the AWS is concerned, we already know the house in which the servers stay is called as the VPC. Now depending upon the architecture pattern, you can go ahead and partition your VPC. So you can say that out of 5 servers, launch 3 servers in the first partition here, and this first partition is called as the subnet. And the architecture states launch 2 servers in the second partition. So 3 servers would be present in the first partition, 2 servers will be present within the second partition. So in AWS terminology, remember that this partition are called as the subnets. Now when you have partition, then you can add an additional layer of security at a partition level. So let's say that John has decided to have an additional level of security, or I would say improvement, in a specific partition of his house. So in order to do that, what John has done, John decided to build 2 entrances so that individual within the partition 1 can directly go out of the house from any of the sides. So you will see that there are 2 entrances to the partition 1 that John has built. Now from this architectural diagram, hypothetically imagine that no doors for partition 2 is present, so that no one can go out. So currently there are no doors which are available. So we are just creating a scenario here. Alright. But for partition 1, there are 2 doors which are available, which John has built. So any individual staying in the partition 1 can go out of both of these doors. Now in terms of AWS, a solutions architect can decide to create a route so that the servers which are present within the subnet 1 can connect to the internet or some other network. So let's say that you have servers which are present within a specific subnet. So that server needs to connect to the internet so that the clients would be able to access the website. So you need to create some kind of a opening to your partition so that you can reach the server as well as the server can reach the other servers which are part of the internet. Alright, so any servers from the subnet 1 can connect to the internet. However, if you look into the architecture of subnet 2, no routes has been created, hence server cannot reach the internet. So as far as the subnet 2 is concerned, we do not see this opening. So the servers that we launch within the subnet 2 will not be able to connect to internet or any other network. Now in many of the organization, if you'll go, there are certain partitions that you will see specifically which are storing very critical data, and that partition or that subnet cannot connect to the internet directly. So that is one of the security measures which are being taken in lot of organizations, specifically if you are dealing with sensitive data. Anyways, when time comes, we can go ahead and discuss in more detail about this, but for now we'll keep it simple. Now sometimes there can be a need of intercommunication. So let's say that there is a need for the servers from the two subnets to speak with each other. So you have server in subnet 1 and you have a server in subnet 2. Now both of these servers want to speak with each other. So however, you see that there is a boundary over here, so they'll not be able to speak with each other. However, if required, you can allow the servers in multiple subnets to communicate with each other. So what you need to do, you have to add a gate over here. So when you add a gate over here, what happens is that any server which are present in any of the subnet will have a path through which they will be able to communicate. Alright, so this gate can be set with the help of routing. Great. So that's the high level overview about VPC, subnets and routing. So before we go ahead and conclude, let's look into it in terms of practical aspects so that we have a better understanding. Now one part to remember is that in AWS, this VPC or this house is automatically created. So you do not really need to worry about it. You can definitely create one more VPC or 10 more VPCs. However, by default, one VPC is created automatically. So whenever you launch a server, it directly goes into the VPC that is being created by the AWS. So I'm in my AWS console and let's do one thing. Let me go to a random region over here. Let's go to Paris region. So basically this is the region which we have never explored. Now within this region, if you go to services and you type VPC, let's go ahead here. Alright, so within the VPC, you will see that there is one VPC which is already created. So on the left hand side, if you click on your VPC, you will see that this VPC is already created by default. Now this is very similar where one of the VPC is already created by default by AWS. Now below VPC you will see subnets. So what has happened is AWS has partitioned this VPC into 3 subnets. Now in this diagram we had 2 subnets. So we had basically partitioned our VPC into 2. Similarly, you can, depending upon the architecture that you need, you can partition your VPC into multiple subnets. Now, each subnet can have a maximum, so you cannot have unlimited servers which can be launched within a subnet. So if you will see that this partition is quite small, you cannot have unlimited number of people staying within a specific partition. If you want more people, then you need to have a more bigger partition. Similarly, a subnet also has its own capacity. In our case, if you see, available IPv4 is 4091. So if you need to launch more servers, then the amount of size that you assign to a partition differs. Alright, so this is what partitions are. And the last thing is the route tables. So route tables are nothing but this route. So if you'll see in this subnet, you have opening to go towards the internet. You also have the opening to go towards the subnet too. So that is what is being controlled by this route table. Now if you go into the route, there are 2 routes which are currently present. One route is associated with the local. So that basically means that any server within the subnet, if they want to intercommunicate with each other, then this is the address. So you see, this is the path opening. So the server needs to know this specific path. So that is what this is. And you have one more path over the destination of 0000. So that basically means that any server that wants to go out towards the internet or towards the other network, then they need to go via this specific path, or in this diagram, this specific path. Alright, so I hope you understood at a high level overview what a VPC is, what a subnet is, and what a route table is. Now, before we conclude, let me go ahead and launch one new server here. So let's go to instances and let's launch a new instance. So whenever you select an instance, currently you will see that this instance is being launched in a specific network. So currently you see the only available option is this VPC. Now since this is a new region and there is only one VPC which is being created by default, our new server will get launched in this specific VPC. Now within this VPC, you can control in which partition your server can get launched into. Now similar to this diagram, let's say that you do not want your server to communicate with internet. You want a very isolated server. So then you can go ahead and launch it in a subnet which is isolated. Similarly, if you want a server to be able to communicate with internet or to be able to communicate with network, then you can launch it in a subnet which has those settings applied. So those are the things that you will be able to control before you launch a server. So I hope you got a high level understanding of what VPCs are, what subnets are, and when you launch a server, the flexibility that you have in terms of choosing a VPC and a subnet. Now do remember that you always have an option to create a new VPC with a custom architecture that you intend to have for your organization. So a few important parts that you need to remember. First is every EC2 instance that you create should be launched under a VPC. Second, EC2 instance launched in a VPC will be protected or not protected based on the configurations that you set at a VPC level. And the third is that the overall architecture that we're discussing in terms of an analogy of a house changes when you go into more technical aspect. So this is a very simple architectural diagram as far as a VPC and subnets are concerned. So currently you see this second layer is basically this VPC layer, and this VPC layer has three subnets over here. And these subnets has a route tables which governs what a server will be able to do in terms of routing aspect. Now at a right moment, we'll also discuss about these 3 points in great detail whenever time arises. However, for now, that's the overview. I hope this video has been informative for you, and I look forward to see you in the next video.